Have you ever considered the possibility of humans living on the moon? What may seem like a figment of science fiction is inching closer to reality. Picture it. Our celestial neighbor, the moon, serving as more than just a nightlight in our sky, but as our next possible home. This isn't merely a dream, but a vision that NASA is diligently working towards. The agency has turned its gaze towards in situ resource utilization, or ISRU technologies. These technologies are crucial for the upcoming Artemis missions, set to explore the lunar South Pole. The primary goal? To extract oxygen from the lunar regolith, the layer of loose, fragmented material covering solid bedrock. Imagine breathing in oxygen that's been harvested right from the lunar surface. NASA's Lunar Surface Innovation Initiative is not a mere dream, but a concrete step towards harnessing the resources of the moon. NASA is not alone in this ambitious endeavor. They have issued a request for information to the lunar community. The objective? To develop in situ resource utilization technologies, or ISRU for short, for the upcoming Artemis missions to the lunar South Pole. As part of this initiative, NASA has introduced the Lunar Infrastructure Foundational Technologies Demonstration, fondly known as LIFT-1. The countdown is on, with proposals being accepted until the 18th of December 2023. But NASA isn't working in isolation. They're teaming up with the industry's brightest minds and leading academic institutions to develop ISRU technologies. This includes a particularly exciting venture extracting oxygen from lunar water ice. The moon, thus, is not just a celestial body to gaze at, but a potential resource waiting to be tapped. But why is in situ resource utilization so crucial to these missions, you may ask? Well, the answer lies in its potential to truly revolutionize space exploration as we know it. ISRU allows us to make the most of the resources we find on the lunar and Martian surfaces, turning what was once barren, inhospitable terrain into a wellspring of vital supplies. Imagine being on a long-term mission on the moon. Your oxygen supply is dwindling, but instead of having to rely on a delivery from Earth, you can extract it straight from the lunar regolith. That's exactly what ISRU is all about. Let's take the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, as an example. This groundbreaking experiment successfully extracted oxygen from the Martian atmosphere, showing us that it's possible to create breathable air on other planets. This technology's potential doesn't stop there. ISRU could also provide water, fuel, building materials, and more, making it a fundamental tool in our quest to venture deeper into space and enable long-term habitation. ISRU, therefore, is a key player in our quest to inhabit the moon. But the moon is not the final frontier. This may sound surprising, but our lunar neighbor is just the beginning of a much grander vision. The technologies being developed for the Artemis missions and the Lunar Infrastructure Foundational Technologies Demonstration have implications far beyond the moon's surface. Take a moment to imagine this. The same in situ resource utilization technologies that will allow us to extract oxygen from the lunar regolith could also be applied on Mars, providing crucial support for future human missions. This is not just a distant dream, but a reality that NASA is actively working towards. But there's more. The Lunar Surface Innovation Initiative, under which these technologies are being developed, is not just about oxygen extraction. It also focuses on surface power, excavation and construction, extreme environment survival, dust mitigation, and extreme access. Each of these components is a piece of the puzzle that will enable us to live and work on other celestial bodies. The moon is but a stepping stone in our journey to explore the cosmos. So it's not just about living off the land on the moon, it's about paving the way for the future of space exploration. As we've discussed, NASA's commitment to developing in situ resource utilization technologies is key. These technologies will allow us to extract oxygen from the lunar regolith, a critical step in sustaining long-term missions on the moon and eventually Mars. The Lunar Infrastructure Foundational Technologies Demonstration is a part of NASA's Lunar Surface Innovation Initiative, an ambitious project that delves into surface power, excavation, construction, extreme environment adaptation, dust mitigation, and extreme access. Each of these elements is an integral part of the puzzle. By mastering them, future human missions to Mars and beyond become not just a lofty dream, but a tangible reality. The moon is our next stepping stone in the vast expanse of space, a testing ground for technologies and strategies that will carry us into the new era of exploration. To continuously be enlightened, like and subscribe, the moon and beyond await us.